Hello everyone, we will continue our class on terror analysis and DEM extraction. Now is the third part, the three-dimensional surface view. First, we will learn to display the three-dimensional files. So we can close this data we have created in the last class, and we just leave the DEM data here, and also we open author image RGB load data. So first we will use the Terra 3D Surface View tool, also in the toolbox. And first we will choose the 3 band we would like to display. Surely we will choose the author image, the RGB, and click OK. Then it appears the DEM associate DEM input file. So we choose the DEM and click OK. And there is several opinions that we can choose. First is the resolution. It's a number of picture checkbox to use for the three-dimensional approach. We can select more than one solution. Typically use the lowest solution where you are determining the best flight path. Then you use a higher resolution to display your final file through sequence. And also select one of the following example modeling: the nearest neighbor and the aggregate. I think you have already noticed the nearest neighbor is to resample using the nearest DEM value. For example, if your DEM resolution is 30 meters and your image resolution is 60 meters, nearest neighborhood ransom use every other pictures and every other lines to create the DEM in the 3D window, and aggregate to average all the DEM values that contribute to the output pictures. For example, if your DEM resolution is 30 meters and your image resolution is 60 meters, picture aggregate resample average 4 pictures to create the output DEM. And also we can enter the minimum DEM value and the maximum plot value if desired. And we will not plot the DEM value lower than the minimum value or higher than the maximum value. And also we can set a vertical aggregation if any to produce the true scale vertical aggregation applied to the z-axis, where high value corresponding to greater express defaulted 5. And also we can select the one of the following image resolution, and also the resampling method. So first, we will choose a very small one. We just click OK. So we have an image like this. We can make it larger, and we can throw the mouse to make it smaller and larger. And also we can hold the mouse and move the mouse to move it. And also we can right-click the mouse to move to zoom in or zoom out. And also there is a mouse button opinions to interactive rotate, translate, and scale surface. You can also control the rotation, translation, or zoom by selecting opinion. Surface control. We have the surface control dialog here. And now we can have some opinions. We can know its, and also we can change the parameters here. This is original. This is original DEM, and if we make it larger, we can have a more clearly mountain, more clearly change of height. And we can see the mouse button opinions. We can read it and rotate the image as we like. And also we can define and display the flight path. When defining a flight path in the 3-dimensional view, you have the choice of using a user-defined path model or the annotation path model. In the user-defined model, you fly through your data based on the file sequence you define. In the annotation model, you fly through the data based on the annotation flight path. The annotation must be drawn on the image from which the surface explorer was created or input from a saved annotation file. Here we will define the flight path in user-defined model. First, we will have the surface control to control the image smaller. And also we will use opinion. Motion control. In the surface motion control, there is also two opinion. Motion user-defined view, as we choose the first one. And also we click the add to add select flight path 1. Flight path 1. And repeat the selection step until you have selected as many as you select. And also we can move the window and add more. And we rotated it. And we add more. Okay. We add more. And also we can and with this, after we have select several projections, we press play. Okay, we'll see. This is play sequence animator fly through. We find it is very quick, so we change this setting. Oh, it's quicker, and we select this, so it becomes smaller. So with this setting, we can set any of the image. We can delete them all, and we start again to create the beautiful scenes. Move it. and replace those. Okay, so we have the image file here. We can create. We do not have some time to create a very beautiful scenes, but when you are interested in some place, you have enough time. We can set the best sequence view and create a beautiful image, beautiful video. And if we would like to save the animation to the file, we can select the file, save sequence as MPEG. So it has the output file size, number of room, and also we can set a name. Click open and we click OK. So we will have the output. We will see what is our output. We open it and we can see the video. It is a very small video, but we can open it large. We can make it larger. When we open the three-dimensional surface view, absolutely, we choose the DEM. In this place, we can set a full image pinning and a full image resolution. In this way, we can create the video with higher resolution. Now I will not show this thing here. I will go to the fourth part, the DEM extraction. In the previous three parts, we use DEM data to calculate some parameters like slope, like aspect, like shadow relief at a specific time or at a specific azimuth and zenith angles. And also we use DEM to do the view shield analysis, use DEM to do the three-dimensional view. Now all these input. Now we will show you how we can create a DEM by ourselves. A digital evaluation model is a regularly spaced raster grid of evaluation values on a surface tile. You can use DEM to produce maps such as contour map, orthophoto maps, and perspective maps. You can also use DEM for route planning in the construction of highway and railway. In remote sensing, DEM are used in mapping, orthographification, and land classification. The DEM extraction module enables you to extract evaluation data from the scanned or digital aerial photos, or from a long-track or cross-track push-boom satellite acquisition that are those from also AST and a lot of images. A long-track stereo image are acquired on the same optical path by satellite, which usually have more than one sensor looking at Earth from different angles. Across-track stereo images are then taken by the same sensor on multiple orbits. The DEM extraction process requires a stereo pair of images containing the radiation polynomial coefficients position from aerial photography or push-boom sensors. RPCs are used to generate type points and to calculate a still image pair relationship. DEM extraction does not currently stop replacement sensor model position. And the DEM extraction model composes several tools, and the multi-DEM extraction is a multi-spatial decision-making process that involves setting numerous parameters. You can run the steps individually from the toolbox or from within the DEM extraction wizard. The wizard guides you through 9 steps. It presents you with the objective parameters such as the minimum maximum iteration of the area of interest, as well as other strategic parameters that depend upon the tile relief, current content, cultural content, image quality, shadowing, and the desired speed of the operation. And in the now class, we will close the data we used previously. Okay, we can close them all. And we can open the data in the data true folder. And that we can have a band A and band F image. We open them. It is a very high resolution area. We can view its metadata. And we'll find it has a very high resolution. Okay, this is also the image in Beijing. And then we can have two pictures in the same, almost in the same place, but in different angle. So we will open the toolbox Terra, DEM extraction, and the TM extraction wizard. New. We'll open this. First, we will select the stereo image. First, we will change A, and we select the right still image. It is F. We have these two images here, and the sense minimum and maximum evaluation. I think they are right. And we click the next. And define the ground control point. There is several. You can choose any of the following opinions. No GCPS. If this, it will result a relative DEM, which is a DEM with possible difference in position, scale, and rotation for geodetic corridors on ground and mid-sea level. Define GCPs interactively. Choosing this opinion would require you to manually enter, load, and edit GCPs that will tie the DEM to a primary position, the result of which would be an absolute DEM. An absolute DEM uses ground controls and have horizontal and vertical reference system tied to the geodetic corridors. And also we can read the GCPS from file. That will would you to select the GCP file from which to read point. For this access, we will not use the GCPs, so the resulting DEM will be a relative evaluation. And then we click the next. In this, we will define the type point. This is very important because the relationship between the still image must be defined by selecting and generating type point. The type point are used to define the epipolar geometry and create a epipolar image, which are used to excite a DEM. When defining type point, you can choose any of the following opinions. Generate a type point automatically. ENVI can generate type point automatically based on the tile features within the image. And also we can define the type point interactively. This opinion we will require we to manually define the type point between the two stereo images. And also we can read type point from a file. Choose this image would require you to select the type point file from which to read the type point. And there is a lot of parameters we can set, and here we can choose the type point because different image will need different parameters. but these parameters generally does not have it does not have a standard. It depending on the image, and we should generally we would need many time to try which parameter setting will be the best. But in this exercise, we have already have a best parameter setting, so we just following this setting and enter the parameters here. And in the description here, you can see the description or the meaning of each opinions. And the number of type point means the number of point. I think it's easy to understand. The search window size. This is the size of search window size in pictures. And the moving window size. Moving window size is the window used for matching, for finding the same type point. And minimum correlation, we can set it at 0.7. And I will not introduce read this, but if you are interested, you can read them. And then we click the next. So it will generate a type point point by point automatically. And now we will find that we have two pictures, and we will see the type point if it's right. This is the first point in the left image, and in the right image we will see, I think it is the same place, and we can click this to see the point 2 also right, point 3, point 4, okay, point 5, point 6, point 7, point 8. Okay, we can navigate between all these pictures, and also if you like, you can also change the pictures. For example, we can move this. We can update this image if you move the image. For example, because we would like to find a point where we can move it back. For example, we do this. We think this is the point, so we click the update. So we will find the 14th point in the right image have moved in this place, at this place, and we move them back. I think we should move them back. We just press the reset to move it back. And also we can delete some point by press delete. And also we can show tables. In these tables, we can also see different points. And also we can manually add the corridors here. After we enter it, we should press update. And in this exercise, we do not have to change any of them. So we just use this setting, because we can navigate all the points. We can find all the type points are right. They are corresponding to the same place on the ground. So it is a very good result. So then, after this, we should click the next. And we have a specific, we would like to specify the DEM output projection parameters. Now this is where we will output our data, output the image file. And we can change the, and then we press next. Yeah, create it. And here, because this is a very high resolution image, we can create also a very high resolution DEM. But here we can reset them to 10 meters. With this image, we can also generate 3 meters DEM. And now we just need to, after enter the 10, we will press enter. It is very important to press enter because only after we pressing the enter, the output X size and Y size will change automatically. And we click the next. Then we have the image here, more than 25. And we will choose the place we will output our DEM. And click the OK. And then press next. It will take some time to generate the DEM. And here we can press load DEM result to display. So we have the DEM data here. Now this is the end of DEM extraction. This is end of DEM extraction, and you can practice this exercise. And if you have any questions, feel free to leave me a message. Leave a message. And thank you for your listening.